Okay, Algebra Video 2 coming at you. So example 3, what is the solution of this system? All right, so we have two equations. Again, one of them is already solved for y. So here we go. So since y is by itself here, take this 3x plus 1, and we're going to plug it in for y right there. So this is going to be 6x minus 2. Instead of putting y, I'm going to open a parenthesis. 3x plus 1. Close parenthesis equals negative 2. So this is just the second equation with 3x plus 1 in place of y. And now we need to do some simplification. So this negative 2 gets distributed in. So we have 6x. Negative 2 times 3 is negative 6. The x comes. Negative 2 times 1 is negative 2. And that equals negative 2 comes down. So now we have three terms. So we combine our x's. 6x minus 6x. Uh-oh. The x's cancel. And negative 2 equals negative 2. So if you remember from topic 1, sometimes you get weird situations where the variables cancel everywhere. And you're left with two numbers, one on the left, one on the right. And you ask yourselves, is this statement true? Does negative 2 equal negative 2? And yes, this is always true. So because it's always true, that means that this is going to have infinitely many solutions. Remember visually, right? If two equations have infinitely many solutions, that means they are the same line, right? So that's a little added bonus from section 4 or lesson 4.1, right? But this has infinitely many solutions. Okay, next. All right, example 3b. Okay, so what is the solution this time? So we have 5x minus y equals negative 4, and y equals 5x minus 4. So again, this time the second equation is solved for y. So take this 5x minus 4 and plug it in for y right there. So I'm going to rewrite the first equation, 5x minus, but don't put the y. And now because it's a minus sign, put the parenthesis, 5x minus 4 equals negative 4. Remember that this is a magical negative 1 that you need to distribute into that parenthesis. So we have 5x. Negative 1 times 5 is negative 5. The x comes. Negative 1 times negative 4 is positive 4. And that equals negative 4. Again, I have three terms here. Combine your like terms. 5x minus 5x cancels. The variable goes away. And we have 4 equals negative 4. And again, we ask yourselves, is this true? And no. 4 does not equal negative 4. This is never true. And because it's never true, this has no solution. And this time what it would mean is that your two lines are parallel, right? They never touch graphically. Okay. Last but not least here, fun little word problem. All right, here we go. It says Nate starts a lawn mowing business. In his business, he has expenses and revenue, right? Expenses and revenue. What you spend, expenses, what you make, revenue. Nate's expenses are the cost of the lawnmower and gas, and his revenue is $25 per lawn. At what point will Nate's revenue exceed his expenses? Okay, so up here, right? Expenses and revenue, right? So his expenses are the cost of the lawnmower and gas, which are here. Now, notice that the lawnmower is a number, the gasoline is a price per lawn, right? So this is going to be the variable, the 200 is not, right? So we need to know that when it says per lawn, that's your x. So x is the number of lawns. Y is then going to be our money. So for the expenses, his equation is y equals, well, there's the $2 per lawn plus the 200 for his lawnmower. Now, the revenue of his business is $25 per lawn. There is no flat fee. So for his revenue, his y just equals 25x. And we need to solve this system of equations. Well, notice that both of them are solved for y, right? So because they're both solved for y, we're just going to take the x portions and set them equal to each other. Essentially, we're taking one of them and plugging in. So I'm going to put the 25x and plug it in for that top y. So we have 25x equals 2x plus 200. And we're going to solve this for x. Now, left side's one term with an x. Right side is two terms, one with an x, one without an x. So you can't combine on the right-hand side. So you have to move and combine the x's. So we're going to move the 2x to the left by subtracting it. And this gives us 23x equals 200. And then we divide by 23. And x is roughly, so 8.69, which we're going to round up to 8.7, and that's the lawns. Right? So what we call this 8.7 lawns. This is called the break-even point. I'm going to just do a quick little graph real fast, right? So when you're doing, a cost graph, so you have your expenses, okay? Your expenses that go up, but you're hoping that your expenses, which is typically like a flat curvish like that, you're hoping that your revenue, so this is the expenses, you're hoping that your revenue eventually exceeds, right, your expenses. This point right here on the graph, this is the break-even point. So anything after that point would mean your revenue is more. So again, the idea here is that when will Nate's revenue exceed his expenses? So Nate's revenue will exceed his expenses starting at 9 lawns. Starting at 9 lawns. You can't mow, 8.7 lawns, essentially. So at 8 lawns, he's still not making money, but at 9 lawns, he's starting to make money. Okay? So I hope that visual kind of helps you see, break-even point and revenue. It's a cost revenue graph, but they use the expenses. All right, so hopefully that helps, and you can solve systems by substitution. All right, thanks for watching.